So in the GAMSAT, this unit conversion can get a little bit tricky. So hopefully that process made sense in the last video, but we need to take it to another level. So very often they might say things. So for example, we had 60 kilometers per hour in 2 meters per second, but they give you things like how many meters in 10 seconds. Now, a lot of people just intuitively know to multiply, but I've actually seen them get stuck. And I'll give you a practice example of why this process of just multiplying your answer doesn't always work. It actually depends on where the unit is that you need multiple of. So the process that I'm going to give you today, I strongly recommend that you get your head around it and use it, is that if you ever see a unit like this, which I call a multiple unit, so not a standard unit like seconds, you've got 10 seconds or 100 grams or 5 minutes or something like that. So if you've got a multiple unit, I want you to get familiar with this concept of a dimensionless unit. So what that is basically we just make up a unit and it only works for that specific question. Okay, so what we say is essentially something like 10 seconds equals one time frame. So we're making up a unit that equals a time frame. So this time frame is only going to work for this specific calculation, and I'll show you what I mean by that. So we'll just do a normal unit conversion process. So we'll have 60 over 1 times kilometers per hour, multiply by hours, 60 minutes. So this is just exactly the same thing as I did last time. So you can see that I've cancelled out all my units, and all I have left are seconds and meters. So this is exactly what we did last time, so nothing special here, but you'll see that the units I have are actually meters per second, and we need meters per 10 seconds. So using this dimensionless unit, we just do one extra step, and it's exactly the same as what we did before. So we just use this unit, this dimensionless unit that we've just made up. So we multiply this by 10 seconds, so it's exactly the same process. I'm just finding the unit that I don't want, putting it on the other side of the fraction, and then on the other side of that, I'm just putting the unit that I want to go into, which in this case is my dimensionless unit, the time frame. So you can see that by doing this, we actually cancel out our seconds unit, and we end up with the units of meters per time frame, and one time frame equals 10 seconds. So, I could rewrite this if I wanted to and just put 10 seconds down here, and it's saying this is how many meters will go in 10 seconds. Now, the reason I do that is it just means that you know how to, what operation to do. So you could, depending on the units, and we'll see an example in a second, these could be the other way around. So it's not always as simple as simply just multiplying by however many of those things that you need. So in this case it is, but it's not always the case. And I think just following this process makes everything a lot easier. So if you want to follow along, we're doing practice test 3, question 29, so the pink booklet. And basically the question is saying how many grays does a 60 kilogram person get during a 20-minute PET scan? And we've got all these units in the question. And this is kind of an example of during a you need. So in this case it is, but it's not always the case. And I think just following this process makes everything a lot easier. So if you want to follow along, we're doing practice test 3, question 29, so the pink booklet. And basically the question is saying how many grays does a 60 kilogram person get during a 20-minute PET scan? And we've got all these units in the question. And this is kind of an example of how complicated unit conversion can get. So really how I define unit conversion is just you have the units for something, but you don't have it in the units that you want. So I think just always start from the end, and the units that we want are grays, right? Which are the same as joules per kilogram. So I always just write that out first. So I want my units in joules per kilogram. And I just let the units just kind of dictate where I need to go. So I know that I need joules in the numerator, right? Because that's where it is. So why don't I just start with one of these units? And it tells me that one annihilation is approximately 10 to the negative 13 joules. So this is how I want you to start thinking is, how could I interpret that information as a unit? So we could just write that as 10 to the negative 13 joules per annihilation, because they've told us that those things are equal. So even though an annihilation isn't a standard unit, this is essentially a dimensionless unit where these two things equal the same thing. So you could have an annihilation in another context and it doesn't equal 10 to the negative 13 joules, but in this context it does. So we can actually just let those two things equal each other, and anytime two things equal each other, you can just have them as a kind of unit like this. And now we can see that this is just a classic unit conversion problem, because we've got the units of joules per annihilation, but we need joules per kilogram. So if we just kind of go through, we can just start doing a unit conversion. So we want to cancel annihilation, so let's just put that in the numerator. And we can see that it says that there's an average of 10 to the 9 annihilations per second. So we can put 1 second down here, 10 to the 9 annihilations there, and then those cancel out. And then just keep going, so just follow your nose, and we can just say there's 60 seconds per minute. So that cancels off my seconds unit. And then we're getting another dimensionless unit here, because to cancel off the minutes, we can see that there's 20 minutes per PET scan, right? And then we can just kind of look at that and we're like, okay, well, what have we got? Well, we've got how many joules there are per PET scan, and we need joules per kilogram. So what we can do is we can see that it says there's a 60 kilogram person. So this is very similar to that 10 seconds example that I gave you before, but where does it need to go? So it's not always as simple as just multiplying by 60. It depends where the unit is. And we can see in this case, kilograms is actually in the denominator. So we need to multiply this by person per 60 kilograms. And if you think about it, that should make sense, because we've now introduced kilograms in here, and 60 kilograms equals one person. So this is why the dimensionless unit is really helpful, because it just allows you to know what kind of mathematical operation you need to do. Do you need to multiply or do you need to divide? So I think get really comfortable with this and practice more and more kind of reading text and thinking, how can I put that into a unit like I've done here, and then where does it need to go? And if you can't just follow the units, it makes it very simple to follow. This, because for example, if we had 5 over 2 times 2 over 3, right, we've got the same number in the numerator and the denominator, and they will cancel out, okay? Because if you think about it, number out. And just to restate, what we want to do is we want to convert 60 kilometers per hour into meters per second. So how I want you to go about this process is write them like this. So 60 over 1 times by kilometers per hour. What we really want to be doing is separating them, multiply this by hours. So put the denominator to make this minutes off, and you can see that now we've basically just said that we divide by 60 to convert from hours to minutes, and divide by 60 again to go from minutes to seconds. And hopefully that just makes a bit of conceptual sense if you think about that.
division steps to do. When we learned basic one-step division, all of the dividends were small enough that we could just use the multiplication table to help us find the answer. But what if we have a division problem like this? 936 divided by 4. 936 is definitely not on our multiplication table. In fact, there's not anything even close to 936. So what do? Well, instead of trying to divide the entire 936 by 4 all at once, let's break this problem up into smaller steps by just trying to divide each digit by 4, one digit at a time, digit by digit. Do you remember how with multi-digit multiplication and addition, we always start with the smallest digit, the ones place digit, and we work from right to left? Well, division is backwards. We still go digit by digit, but the other way. We start by trying to divide up the digit in the biggest number place first, and we work our way from left to right. So the first step in this problem is to divide the first digit of our dividend by 4. We'll just ignore the other digits for now. That makes it look like we have the division problem 9 divided by 4. Great, that's easy. It's just a basic division problem like in the last video. So we ask, how many 4s will it take to make 9, or almost 9? Well, 2 4s would be 8, and that's almost 9. So just like before, we put the 2 in our answer spot on top of the line. But wait a minute, there's a lot of room up there. Where exactly do we put it? Well, the answer digit should always go directly above the digit we're dividing. Since we're dividing the digit 9, our 2 should go right above the 9. Okay, now we multiply. 2 times 4 is 8, and the 8 goes below the 9 so that we can subtract. Digit should always go directly above the video. So we ask, how many 4s will it take to make 9, or almost 9? Well, 2 4s would be 8, and that's almost 9. So just like before, we put the 2 in our answer spot on top of the line. But wait a minute, there's a lot of room up there. Where exactly do we put it? Well, the answer digit should always go directly above the digit we're dividing. Since we're dividing the digit 9, our 2 should go right above the 9. Okay, now we multiply. 2 times 4 is 8, and the 8 goes below the 9 so that we can subtract to get our remainder. 9 minus 8 is 1, so our remainder is 1. Now at this point, in our basic one-step division problems, we would rewrite our remainder up in our answer with a little r next to it. The 9s directly above the digit we're dividing. Since we're dividing the digit 9, our 2 should go right above the 9. Okay, now we multiply. 2 times 4 is 8, and the 8 goes below the 9 so that we can subtract to get our remainder. 9 minus 8 is 1, so our remainder is 1. Now at this point, is 9 and the 8, now 9, our 2 should go right above the 9. Okay, now we multiply. 2 times 4 is 8, and the 8 goes below the 9 so that we can subtract to get our remainder. 9 minus 8 is 1, so our remainder is 1. Now at this point, in our basic one-step division problems, we would rewrite our remainder up in our answer with a little r next to it. But we aren't going to do that yet because this is long division and we still have more digits to divide, the ones we've been ignoring. Since we're going digit by digit, let's stop ignoring the next digit in our dividend, the 3. Now you might think that our next division step is to divide that 3 by the 4, but it's not quite that simple. We had a remainder from our last division step, and we can't just forget about that. We need to combine that remainder with our next digit and divide them both together. We do that by bringing down a copy of the next digit, the 3, and put it right beside the remainder, which is 1. When we do that, it looks like our remainder is 13. It's kind of like our remainder is teaming up with the next digit over. And if you think about it, that makes sense, because the digits that we were ignoring during our first division step really are part of the remainder because we still need to divide them. Okay, so bringing down that next digit makes our remainder bigger. And that's good because before the remainder was so small that 4 couldn't divide into it. But now it's 13 and 4 will divide into 13. So we ask, how many 4s will it take to make 13? Well, 3 4s would be 12, and that's really close without being too big. So let's put 3 in our answer line. Yep, it goes right right over divided. We need to division. Basic is 8. Answer digit should always go directly above the digit we're dividing. Since we're dividing the digit 9, our 2 should go right above the 9. Okay, now we multiply. 2 times 4 is 8, and the 8 goes below the 9 so that we can subtract to get our remainder. Nine minus 8 is 1, so our remainder is 1. Now at this point, in our basic one-step division problems, we would rewrite our remainder up in our answer with a little r next to it. But we aren't going to do that yet because this is long division and we still have more digits to divide, the ones we've been ignoring. Since we're going digit by digit, let's stop ignoring the next digit in our dividend, the 3. Now you might think that our next division step is to divide that 3 by the 4, but it's not quite that simple. We had a remainder from our last division step, and we can't just forget about that. We need to combine that remainder with our next digit and divide them both together. We do that by bringing down a copy of the next digit, the 3, and put it right beside the remainder, which is 1. When we do that, it looks like our remainder is 13. It's kind of like our remainder is teaming up with the next digit over. And if you think about it, that makes sense, because the digits that we were ignoring during our first division step really are part of the remainder because we still need to divide them. Okay, so bringing down that next digit makes our remainder bigger. And that's good, because before, the remainder was so small that 4 couldn't divide into it. But now it's 13, and 4 will divide into 13. So we ask, how many 4s will it take to make 13? Well, 3 4s would be 12, and that's really close without being too big. So let's put 3 in our answer line. Yep, it goes right over the 3 because that's the next digit we were dividing in this digit by digit process. And then 3 times 4 is 12, which we put right below the 13 so that we can subtract to get the next remainder, which will also be 1. See how we're just repeating the basic division procedure, but we're going further down the screen as we do. All right, now that we have a new remainder, it's time for our next division step. Let's stop ignoring the last digit in the dividend, the 6, and bring down a copy of it to team up with our new remainder. Together, they form a remainder of 16. Aha! That's good because it's going to be easy to divide 4 into 16 because 16 is a multiple of 4. It takes exactly 4 4s to make 16. So we put a 4 in the last place of our answer line, and then we write the 16 below our new remainder. Now, if we subtract 16 from 16, we see that our last remainder will be 0, which means there's no remainder left. That's great. We solved the whole division problem digit by by digit by breaking it up into 3 basic division steps. And now we know that 936 I thought so. Let's divide 315,270 by 5. Now don't worry, it's really not that hard if you just go digit by digit. I'm going to work the problem pretty fast, so don't worry if you don't follow all the math. Just focus on the repeating division process as we go along. Are you ready? The first digit is 3. How many times will 5 divide into 3? 0. 5's too big, so let's just skip that step and combine our first digit with our next digit. So how many times does 5 divide into 31? 6. 6 times 5 is 30, and 31 minus 30 gives us a remainder of 1. Now on to the third digit. We bring a copy of it down to join with the remainder. And we ask how many times will 5 divide into 15? 3. 3 times 5 is 15, and 15 minus 15 is 0. On to the next digit. Now even though our previous remainder was 0, we still bring down a copy of the next digit. Now we ask, how many times will 5 divide into 2? 0. 5's too big, so we need to move on to the next digit and bring a copy of it down also. There, that's better. Now we ask, how many times will 5 divide into 27? 5. 5 times 5 is 25, and 27 minus 25 gives us a remainder of 2. Now for that last digit, which is a 0. And you might wonder, why do we even have to bring a copy of a 0 down?
Ola. What is it? Okay. Mm-hmm. I'm gonna be totally honest with you. I'm not very good at this. Okay. Alright, give me 2 seconds. You caught me right in the middle of something. Give me like 2 minutes just to wrap this up. I was just reading something. Give me 2 minutes and then I'll be with you. Two. Yes, Winnie, I know, can't just fucking sit still, bro. What? Oh, sorry. Oh, my bad. I was just the dog was dog was trying to jump on me. uh,
Isn't that nothing? But the 0 is an important placeholder. And when we bring a copy of it down, it changes our remainder of 2 into a remainder of 20. Now that's
Let's now see if we can do 2 times 3 all the way up to problems like arc 6 times 3. So 4 never hurts to get a lot. Why they call it long. It's the same thing, other ways to equal to 20. 4 goes into, and it's actually the same thing, and you probably haven't seen this notation before, as 2,292 divided by 4. This, and this are all equivalent statements on some level. And as you can see, you say, hey, Sal, that looks like a fraction, in case you have seen fractions already. And that is exactly what it is.
Alright,
It is
I'm with
a
you. And how much remainder? You lost me. You're just basically teaching this to me. I'll be honest with you. This is not. I genuinely don't know how to do this. Okay. Okay. Can't you shave off 2 zeros from either number to make it easier? Oh, okay. 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 I can do it right now for you real quick if you get the numbers back up. Three 90,000 divided by 3,600. Yeah. Not quite, mate. 25. I mean, yeah, well, like if they both end, no, 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 no. Like if you do 90,000, right, 90,000 again. So like because what you can do is make it 36 divided by 900 by shaving off 2 zeros from either number. And then when you get the final answer, you'll, mm,
Fraction. But anyway, I'll just focus on this format, and in future videos, we'll think about other ways to represent division. So let's do this problem. So 4 goes into 2 how many times? It goes into no times. So let's move on to, let me switch colors. Let's move on to the 22. 4 goes into 22 how many times?
oh, well, you only move on to a greater number if it doesn't fit in. Oh, okay. Can you keep playing the video?
Let's see, 4 times 5. 4 times 5 is equal to 20. 4 times 6 is equal to 24. So 6 is too much. So 4 goes into 22 5 times. 5 times 4 is 20. There's going to be a little bit of a leftover. And then we subtract. 22 minus 20, well, that's just 2. And then you bring down this 9. And you saw in the last video exactly what this means, right? When you wrote this 5 up here, notice we were in the hundreds place. So this is really a 500. But in this video, I'm just going to focus more on the process, and you can think more about what it actually means in terms of where I'm writing the numbers. But I think the process is going to be crystal clear, hopefully, by the end of this video. So we brought down the 9. 4 goes into 29 how many times? See, 4, it goes into at least 6 times. What's 4 times 7? 4 times 7 is 28. So it goes into at least 7 times. What's 4 times 8? 4 times 8 is 32. So it can't go to 8 times, so it's going to go to 7. 4 goes into 29 7 times. 7 times 4 is 28. 29 minus 28 to get our remainder for this step in the problem is 1. And now we're going to bring down this 2. We're going to bring it down, and you get a 12. 4 goes into 12. That's easy. 4 times 3 is 12. 4 goes into 12 3 times. 3 times 4 is 12. 12 minus 12 is 0. We have no remainder. So 4 goes into 2,292, exactly 573 times.
Okay.
So this
All right.
2,292 divided by 4.
All right. Well, what? Why? What? No, but he started. Okay, so all right. So if it's a but it, okay, but if it's a multiple digit number, you start from right to left. You go right to left, not left to right. I don't know. You tell me. Does he do one with a two-digit number? Does he do one with it? Does he do another example later that has a two-digit number? That's helpful. Okay. I don't know. It's a bit counterintuitive. Like, yeah, you're dividing like the lowest significant figure by the highest significant figure of the other number. So, I don't know. Okay. Okay. Once. And then What? Dude, that's not that. No, he didn't. He was just calculating. He was just calculating what's left over.
5
Okay.
times 4 is 20.
Okay. Right. $300.
Be a little bit of a leftover.
Directly
Then we
out.
subtract. 22 minus 20, well, that's just 2. And then
No,
bring down.
you don't write 600. You don't write. You never. You never write the 600. Do you? Oh, you do. Okay.
A little bit of a leftover. And then we subtract. 22 minus 20, well, that's just 2.
So write it underneath the six. Yeah, write it underneath. Write 300 underneath. No, I think it's just directly underneath. Okay.
Then you bring
I don't
down
even know
this
why you
9.
asked me, bro.
And you saw in the last video exactly what this means, right? When you wrote this 5 up here, notice we were in the hundreds place. So this is really a 500. But in this video, I'm just going to focus more on the process, and you can think more about what it actually means in terms of where I'm writing the numbers. But I think the process is going to be crystal clear, hopefully, by the end of this video. So we brought down the 9. 4 goes into 29 how many times? See, 4.
Okay. Don't you then do? You just have to do a different, like, you just have to get an example that has like it's like a 3-digit number divided by a 5-digit number, isn't it? Doesn't that say 7200? I can't see it. But it's no, but it says there's a 2 in the brackets as well. It's 2 bracket 3600 times 2. That is 2. Subtract 90,000 from. I mean, it got to the answer, so it's got to be doing something. But look, 90,000 minus 70 or minus 72,000 is 18,000. 3,600 into 18,000. I can't read those numbers, but I think that says 18,000. Whatever, dude. I don't know how to do this either, so it's really just the blind leading the blind here. I don't think it's year 6 shit. I think when there's multiple digits, there's probably an extra trick that you're missing. It sounds like you're just jumping the gun. Like there's probably another step that precedes this that you're just not doing. I want to do this, bro. Yeah. Okay. $24. $27. 0 remainder. $27. $275. 91.6 repeat. Is it? have to multiply the remainder by 3, because that would make sense. Just get to the answer then. Why did you put the remainder 2 up the top though? Yeah, keep going. Well, okay, try it with the first digit now. Try it with the like doing 3 first. Yeah. Okay. 9. But then what do you do with the 0? So 92, you think 30 goes into 275? But that doesn't make why would 30 go into 275 91 times? That's not logical. Yeah, I know, but what about the 0, bro? You're missing a step. There's a piece of this that is missing. Like you're forcing a problem solving thing that is
4. It goes into at least 6 times. Let's now see if we can divide into larger
okay.
numbers. And this is a starting point.
Well, like there's obviously a way to do it. Ask Claude, how do you by hand divide a? No, I'm doing it. Fuck it. Let me fucking do it then. Cunt.
G'day, welcome to the Tech Match channel. Multiply. Remember that order, and the first thing we do when we, let's start off with our steps here. The first step we have is how many times does to 6 to 12? Always working out, well, 6 does not go into 3. Group these 2 digits together. Track that away. Set it out exactly this. We have 9 divided by 4, not 11 divided over to take it up 35. Go, practice and subscribe, and leave me a comment telling me what you thought.
Okay, so okay.
It's Professor Dave. Let's learn how to do long division. Small number steps. But this elegance of applying what? And write a 0, 2, and then we bring down the 9. 11 does fit into get a 0 down by 11. This 3 is meant to be the reverse of multiplication. Let's try one more for practice. 397 divided by 11. This time we have to divide by a 2-digit number. 11 doesn't fit into 3, so let's put a 0, get a 0 down here, which leaves us with 3. Then we bring down the 9. Eleven does fit, which leaves us with doesn't fit into 3. So let's put a 0, get a 0 down here, which leaves us with 3. Then we
I think you just do
bring
instead
down
of
the 9.
doing how many times does 0 go into 9, you just do how many times does 3600 go into 9000. And so you would just work out, it would be twice, probably. What? No, yeah, I don't understand. Like, what did I say, what did I say that was wrong? What? Wait, what? What do you mean 3.6 divided by 90? That's easier? A decimal value is easier? Like what? Okay, what? But you see what I mean? Like, I don't understand why like do a different pick. Like this is I was actually like Claude is doing it the same way I did it, where you shave off a couple zero, like you shave off 2 zeros from each number, so you're doing 36 over 900, which you can simplify into if you divide 36 goes into 9, so you can simplify that into 4 over 100, and then you've got, which is the same as 0.04, and then you just multiply fucking you just literally just fucking multiply 9,000 by 0.04. But because you've picked an example that is like, you don't, long division is impractical. But the way you would do that in long division is you would do, how many times does 3600 go into 9000? Would you not? But I don't understand. Could you not just do like 3600 go into 9000? Yeah. What's 3600 times 2? You could work that out by hand. You could guess. You could work it out that easily in your head. 4200, right? 3600 times 2. No, it's 6,000 plus 7200, 7200, 7200. 7200. What do you mean take out? You're not doing it correctly though, Zeke. But you're forcing a system that doesn't, you can't just take parts of that number. That dude's not doing, like, on the YouTube video, He's not doing how many times does 1 go into 3, 1 go into 9, 1 go into 7. He's doing how many times does 11 go into 3, 0. How many times does 11 go into 39? You can't split up the number on the left if from the seams of this way that you're doing it. You can't break it up and do it in parts. You can't do like the zeros first, then the 6, then the 3. He does 11. Yeah.
Let's try one more for practice. 397 divided by 11. This time we have to divide by a 2-digit number. 11 doesn't fit into 3, so let's put a
Yeah, 11. He doesn't go 1 into 3. How many times does 1 go into 3? Okay. Into 9,000. Yeah.
0. Get a 0 down here.
Yeah.
Which leaves us with 3. Then we bring down the 9. 11 does fit into 39 3 times.
You would just keep going. It would just keep being zeros until you got to 9,000 anyway. So you may as well just start at 9,000. So you don't have to do all the zeros because it's just going to keep the number. You're just going to keep adding zeros the whole time. Okay. So do it into 90. It'll be 0. So put a line underneath. Yeah. 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 Well, you need to do 90. 90 minus 0 is 0. I mean, sorry, 90 minus 0 is 90. Yep. Then you bring down the next 0. Great. 3,600. And then you do divide by, what do you do, 900 now? So it's 0 times. Yeah. So, no. Yeah. Well, you skipped a step. So, yeah. You added an extra 0 there. It's 0. Yeah. There you go. Then how many times go into 9,000? One, it goes twice. So you add the 2 up the top. That 0 you have up there doesn't actually go to, oh, I mean, I can stay there, but whatever. You would put 2 other zeros there, but it's, yeah. And then how many remainder? So then you would minus yep, 70, 7,200. Yeah. So just, yeah, 720. Sorry, 7, yeah, perfect. So now do that. Yep. Then you bring down the next digit. Is that it? No, there's one more probably. And then you do, how many times is 18,000? So what you would do is you would, like on another piece of paper, you would do, what's 3,600? You know what it times by 2 is, so just do now times by 3. What would it be? And then you would keep progressing until you figured out, until you surpassed 18,000, and then you know that value is too much. So if you do by 10, you know it's going to be 36,000. I think this is more chance of making a mistake. But yeah, continue. You could again, because you could again take the 2 zeros off at the end to make this easier for you. So like if you did 36, how many times does 36 go into 180? That's a lot more manageable. Yeah. No, that's good. No, that's right. Yeah, that's right. Well, yeah, I mean, it's going to be hard because you picked an enormous number divided by an enormous number. They're not going to they're probably not going to give you this. Like you'll never have to do this in an exam, I don't reckon. But all right. Well, you got it. Next. 6. Yeah, good. Next. 182, I think. 82. Bang. There you go. So how many times is that? Well, yeah. Maybe with the remainder, do you like add something back over with the remainder? Like, is there a thing where you... All right, just finish it. You just finish it. Yeah. So you got to add the zeros back. What do you do with remainders? I think there's something that you're
So we put
missing
a
with
3,
the trick
multiply to
with
get
the
33,
remainders.
subtract to get 6, and then pull down to 7. 11 fits into 67 6 times. So we put a 6,
There wasn't
multiply
that.
to get
I mean,
66,
I
and subtract to get 1. 11 doesn't fit into 1, and we've run out of digits in the dividend. So that will be 36 with a remainder of 1. If we don't like these remainders, we could keep going to get decimal places. Just put a decimal here.
So it's just a decimal place value. One sec. So nah, it fits perfectly. Well, we've done something wrong then. There's something we've done something wrong along the way, I guess. Can you scroll down to the bottom? What were we trying to do? It was 18,000 divided by 3,600. Oh, 18,000. Oh, we did kook it. 3,600 goes into 18,000 exactly 5 times. So we've messed up the maths, I suppose. So 36. Yeah, we messed up that list that you have on the left there. Yeah, messed that up somewhere. So 36. So 72, 108, not 110. And then 144, then 180. Okay. And then that's how you do that. Yeah. Do one that doesn't just have a bunch of zeros. Do like 1,250. And then on the inside do 25217. No, what are you doing? No, add another number to the end. Add like a 6 or something to the end of that. No, not another 0, bro. A 6. Like yeah, like 586 or something. Yeah, fuck. Yeah, do that. Is that a 7, that first number? Okay. You already cooked it. You could just start at the first one. Okay. All right. All right. All right. All right. Yeah. The 1. Okay. You didn't bring down the numbers. Yeah, so you do 0. Oh no, you did. It was just another 0. My bad. And then you bring down the 0. And another 0. Down the 8. Bring down the 8. That's actually insane, but that's like keep on. I'm not commenting on you, I was just looking at something else. Something is not right. I think you've cooked yourself by making it this long. Try just start at the first. They're all going to be 0, so just try start at the first number that it can. So 7,108. I don't know why you make it so difficult for yourself. Okay. Alright. So what's 2781 times 2? No. Yeah. Or just do the working out on paper. You can do that. 2781 over 2. You know how to do that, right? You did the multiplication thing. Didn't you do the multiplication one where you like draw the line, you put the 2 down the bottom, and then you do the working out? Like, yeah, just do it like that. Play it safe. No need to. So just eyeballing, you know it's not going to be two. It'll go in at least twice because it's 7. Like, okay, do the working out. Yeah, you should just start at 3. You should just do times by 3. If you can like do the line thing, but with a 3 on the bottom. Just do it. Just do it. 5? What's this? What's that 5 or whatever? Oh, is it? Oh, okay, sorry. That's very wrong. I don't know what you did. I don't. Oh yeah, no, no, that's not it. No, it's not right. No, no. Don't you don't you do 18? Don't you do you do do you do 2 times 3 and then add 4, or do you do 3 times 6? Do you add the 4 to the 2 beforehand? Yeah, and 2 there. Yeah, there you go. No, I think you're getting you're putting the wrong number down the bottom. I think it should be like. No, you're putting the wrong digit up the top. It's 4 down the bottom and 2 up the top. Yeah. Mhm. Mhm. 8,343. No, it's a 7, not a 2. Your handwriting's just cooked. No, no, no. The second digit is a 7. So it's 2781 is the number up the top. Yeah, do that. Much better. 6 and yeah, plus 2 is 8. There you go. 8343. Perfect. That's it. So yeah. So it's 2. Yep. Then you do. Wait, what? I think you. Yeah, I think you might have skipped a step. No, you want to do the remainder. So you want to do the number, like you want to do minus the two, yeah. Yeah, 2. But then you would usually like bring down all those numbers and stuff to remember. Minus. I've confused myself now. Oh, yeah, maybe you do have to bring down all the numbers. Maybe you do have to do it like sequentially. Keep what we just did, like that stuff on the left, but just rub out everything under the fraction for a second and just do it like how that guy does it in the video. So like put a 0 under the 7 and then draw a line under it. And then under that you do your, can you get rid of that 66 or whatever, that line under that? Yeah, all that stuff. Yeah. So then you would do so you have a 0, then you do the next one, it's the 71. So 0 minus 71 is 71. Right? Yeah, am I doing that right? Is that how you do it? 0. 8? Is it? There's a 0 there though. So it's like 278 into 710 is another 0, and then you bring down the. Mm. Mm-hmm. Okay. Yeah. Yeah. Is that right? Okay. Yeah. Yeah. So you have to bring down another 0. Then we got our number, which was 2, right? It was 2 with a remainder. Yeah. So 8343 it was. Oh yeah. Wait, what? Oh yeah. Yeah, yeah, no, no, no. You're right. You're right. You're right. Yeah, no, you're right. Keep going. Okay. I don't know. I've never. That's. I don't know. I don't know what to do in this situation. Okay. Um. Uh, okay. No, I think you're right, bro. I think you're right. You're right. It's 18. It's 18. You got like I think you can do that. you could, I reckon, you Zeke Hodges could subtract any two numbers, any two-digit numbers from each other in your head. Like I don't think you'd need like uh, mhm. Let me have a look. Yep. Yep. So how many times does 2761 go into 16,184? Right? So what you would do, you like give a rough estimate. So do like, let's say, like how many times does how many yeah, how many would that be? 3, 6, 9, 12, 8, 15. So do like 5. So just on the left again, do another multiplication thing where you do 2781 times, let's say 5. Yeah, do that. 40, I think. 5, 10, 15, 20, 25, 30, 35, 40. Cool. Hmm. Okay. So that still fits. Do you reckon you could add another one? Probably. Try 6. So add 2781. So by 2. So you know it's 5, and then yeah. Well, it would be 6. No, it was wasn't it? It was times by 5, right? It's not definitely not 3905. Is is that a one? Is it supposed to be 13905? Like what is going on? Well, what's 5 times? No, it was because 2 times 5 is it's yeah 13. 13905. Yeah. Yeah. 84 minus 5 is pretty easy. 79. Oh, you got it though. Is that what you're supposed to do when it's like the? Oh. And 0, I guess. Is that the remainder? Or is this something else now? You forgot the 5 though. You forgot to write that it goes in 5 times. So up the top you would write a 5 next to the 2. Because it goes in 5 times. Yeah. So you were so close. It was perfect. Yeah, that's why I said that's crazy when I went before. Because it goes in 25 as well. You almost guessed the numbers. Okay. But your remain like so the actual number is like I'll just read you 2 decimal places, but it's 25.56. So it's something with the remainder, that last one went wrong. Okay. Yeah. Um no. I just said 25.56. Did we forget down to like bring something down or some shit? I'll ask. I'll let me ask Claude real quick. Well, even fucking wait. Wait, what? If you want it as a decimal, continue past the decimal point by bringing down zeros. What? So confused. Wait, can you go to the? Can you show me the? So what would it be? The what's your final answer? Well, how the fuck did Claude get it? I don't understand this like last thing that it's saying. No, no, no. It says it says the remainder is 1559. And then it said like if you want it as a decimal, continue past the decimal point by bringing down zeros. I'm confused. Can you make your paint thing bigger just so I can see all like the numbers and shit? Just hit like the. Yeah. Yeah, so 7180 over 5562. Yep. Cool. Bring down the next digit by bringing down the 4. Yep. Does 2781 go into 15464? Try 5. Okay, well, it gets to that anyway. So 13,005 fits. Yeah, 13,905. Yeah, cool. Too big. So the second line is 14,164. What? 14,464. Where is it getting that from? 15,000. Hang on. I did, but I want to see the working out, bro. 25.56 is the answer on a calculator. 71,084 divided by 2,781. Yes, that's it. Oh, yeah, yeah. Mm-hmm. Yeah, yeah. Mm-hmm. 4279. No, it's 56. 56 something. So hang on. There's something here that we're missing. So 15. Hang on. Yeah. So the first two digit is 2. Oh shit. Fucking rip my shit. First two digit is. Do something wrong? Oh, we did. You wrote 7180, not 7108. See in the third line on the left column, in the left one. Up one section, up one another line, up another. Yeah, that number. You wrote 7180, and the number is 7108. You brought down an 8 instead of a 0 on that third number. Do you know what I mean? I really wish you didn't rub everything out, but that's fine. But you can do that. So like I said, an easy way to do it is to shave off 2 zeros, and then it makes life a little bit easier. But yeah, it is. Like procedurally. 900 divided by 36. Yep. Yep. Why don't you just do it, write it out how we just did it? Why are you doing it? No, you wouldn't. Be significantly less than what we just did. Like with that. Okay, well, don't make that mistake. Like then write the working out for that as well if you're not confident. Like you know 3 goes into 9. You know 3 goes into 9 3 times at least. So you know it's not going to be it can't be more than, I mean, sorry, 3 would go into 9. Yeah, 3 goes into 9 in 9 3 times at least. And then you like add the 0. So you know it's not going to be sorry, one sec. Yeah, you know it's not going to be like probably more than 30, right? So you can skip a lot of it, because then you could just do 36 times 30, see where you land. If it's too much, go down a couple digits. Well, like 30, 30 is going to go over because 30 times 30 is 900. So, and it's 36. So, start at 25. So do 36 times 25 over each other. You know what I mean? Yeah, like do it. Go the full. Yeah, 3 is 9. 30, yeah, cool. Bring down the next number. Well, 900. I mean, sorry. 36 into 90. You do, right? In the next line. Show me the YouTube video again for 2 seconds.
Here and add a 0. Drop it down to get 10. Reveals.
No,
It works just like our
it was
instead
in
of
a good
value
position.
we place the
No,
first
go
number
back
of
to
the
where we
dividend
just
inside
were.
this, and we've run out of digits in the dividend.
Yeah,
Could keep
now
going with
pause
digits
it.
incorrect to get 1. 11 doesn't
Pause
fit
it.
into 1, and we've run out of
Pause it.
digits in the.
Now scroll. Yeah. So you have 0 at the top because 11 goes into 3 0 times. Then okay. Yep. Why have you cooked it? Go to the YouTube video then. Okay. Okay. So 180. How many times? So you know how many times does 3 go into 18, for example? Just why are you doing make it so hard? There's more room for error. I don't know. Okay, whatever. Just like, okay, so first get an estimate of where of how many times it's going to go. So just as an estimate, we're going to remove one significant figure from the end. So right, so how many times does 3 go into 18? How many? What? Okay, let's go from there. Okay, perfect. No, we're not done. Yeah. Well, yeah. Do you know what I mean? And then you add, you have to add the significant number. You have to add the things back on, right? Because you took away 2 zeros from the end. That's okay. Didn't you simplify that? Yeah, because you did 90,000 divided by 3,600. You simplified it to 900 divided by 36. So you have to add, so it'd be 2,500, no? Let's check. 3,600 time, I'm doing 90,000. Oh yeah, true. Yeah, it's true, true, true. Yeah, well there you go. See, like you didn't have to do 90,000 divided by 3,600 because you know what I mean? And like you did it, I don't know, like if you were like just reasonably okay at that can you can do that in 3 minutes or less. Does it? Yeah, yeah. But I don't think you would have that like quite. It would more be like what's 12 divided by 400 and something. You know what I mean? Like it wouldn't be like these crazy high long division numbers that we're doing now. Like we're doing it much harder. I think if anything, you're psyching yourself out by doing these crazy high numbers. So how did you get to 90,000 like easily? Like did you get to that get it to 90,000 divided by? Mm. But that like to get to 90,000 divided by 3,600 or whatever, that was you got there easily. And then yeah, how many what about the meters per second though? Yeah, but how did you get to 3,600? Why 60 times 6? I'm genuinely like, I don't know how you did that. You lost me. Anyway, it doesn't matter. Good job. Fucking, I'm glad you understand it, because I fucking don't. Yes. Mhm. What about this hour at the bottom, the numerator there? What's that? Okay. Is it over an hour? Like 90 over H, 90,000 over H? No, isn't it H? Wouldn't it be one H, like just H? One H? So this hour's just vanished into the fucking. Oh, right. Okay. But you cancelled them both out in that line above. So where's that KM coming from? Fuck! What the fuck? You're just pulling it out of thin air. Wait, is this are you solving this from the line above? Is this a continuation from the line above, or you're rewriting it a different way? Right, so you converted 90 kilometers an hour into 90 meters per hour. Sorry, you converted what's 90, yeah. So you converted 90 kilometers per hour into meters per hour, which is 90,000. Yeah, okay. I'm with you now. Seconds. Oh, and then you want to go minutes into seconds. So you times that by 60 again. Why are you doing why are you timesing them like one after another? Is that right? Why? So you have four fractions multiplied by each other. What is this times? How do you even solve this? It's not like even possible. You put way too many fractions. Yeah, what the fuck? You could just do 90,000 over what, like 90,000 times. think you just write it as a singular fraction. What, can't? I don't understand this. I'm gonna go eat dinner anyway now though. Good luck with all your fucking adventures, mate. I don't get this way of writing out where it's like 90/1 times kilometers over 1 hour times 1,000 over km times, like, it just doesn't, I don't get it. Why you're multiplying them all by each other. Okay. Well, I don't want to learn and I don't need to learn how to do this, so I wish you well. Uh, I'm gonna go have dinner. Bye. Okay. All right, bye.
Yeah. Okay. I had the results this month and it's all bad. I had 40 overall. And I got that 3 times and yeah. Yeah. But I don't want to give up, so I'm gonna do it again in September. Yeah. Uh, I'm trying to find other ways by creating maybe a timetable and other stuff. I tried to find there's a no online, but I couldn't find it because I don't know how to get there. I tried eBay and then I had Gumtree, but I couldn't find any where I am. So I don't know how to access that. And I'm looking for There's a Nail book, if that's helpful. That's what I had. Although I really appreciate it. Well, thank you. Uh, I've cried a lot. I don't know what to do. I'm devastated. I don't know what to do. I've tried everything. I even paid a tutor and it still didn't work out. Mm. So you're doing maths now? Yeah. Oh, okay. Yeah, it comes in. It's very small, but you won't see it the way it's written in the exams. You won't know. Yeah, the phrase is in a way that you will be confused and you know what either is math, either is science. You don't know. They're all mixed up in one question. I can't find it. I'm new to this, so it's gonna be a bit. Oh yeah, yeah, found it. Wait 1 second. Oh yeah, all right. I'm on the phone now. Okay. All right. Let me try and see. I'm so new to this. Wait 1 second. All right. Are you fully prepared for the? Do you have an exams in September, or you just wait for next year? Okay, that's what I'm doing as well. And I'm still trying to like plan a timetable to do it properly. Okay. 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 All right. All right. Thank you. Are you in Australia? Where are you located? Oh, okay. All right. I'm in England, so it's a bit time differences. Yeah. It's 10 hours. Yeah. I think you're 10 hours ahead of us. It's 11 now, so 11 a.m. Should I send you an email, my email or something? I don't know. How do I do that? Yeah. 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 Okay. How did you find your exams in March? That was it. Oh, okay. Yeah. Oh. Oh, that's nice. I never got 50. I've written 3 times, all in 40. And I keep wondering what I'm doing wrong. I don't know what I'm doing wrong. I don't really know. I don't. Section two last the yeah in last year September I had 47 in section two. This year I had 40. I don't know why I did wrong. Whether I don't know. And I think the section three as well too. I don't know what I'm doing wrong. Maybe I need to like take my time and then study each topic. And I don't know how many topics I have to study. It's a bit confusing as well. Yeah. Yeah. Sometimes I doubt myself that it's wrong and it's actually wrong. Yeah, I bought like two of them. I think two. Yeah, two papers from ASA. It's been 2 years now that I'm using the same paper. Do I have to buy a new one or just use the old one? Yeah. Okay. 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 Yeah. Yeah. Okay. All right. Yeah. Oh, it's just frustrating. It's just I don't know. But I don't want to give up because that's my dream. I don't want to give up on that. So it's just yeah. Yeah, I still want to do it. Okay. So you're on here every day or just what time? Yeah. Okay. All right. I'll join you when I can and then study together. I just need a steady body and I can just yeah know what I'm doing. Okay. All right. I'll do that. Yeah. Wow. Did it help you with that with the exams? All right. Because I heard it's helpful, so I want to try that. I tried going on eBay to get one. I couldn't find any. I tried searching on like I was searching, I couldn't find any. I was like, okay, I give up. Yeah, this is quite fine, but I can't download or nothing. It's just there. I don't know how. No, I don't get anything. It's just there. I don't know. Yeah. Okay. And also, if possible, can you send me a copy of the bills? And I want to see how it is. Yeah. Okay. Do you have a topic you study every day or just? Yeah. Okay. Yeah. Yeah. Oh, okay. All right. Okay. I'm trying to like create something to do with it, the questions as well. I'm trying to like create a spreadsheet as well. I found something online, but I'm trying to do it and I'm just struggling with it. So I'm gonna try again and see how it goes. Oh, yeah. Yeah. Oh, okay. In my email or just. Oh, okay. All right. Oh, that means I need to download this code on my computer then. Oh, okay. It's loaded. Yeah, I'm trying to see whether it's gonna open or not. So I'm trying to, you know.
Effort is not
Oh yeah, it's open. Oh yeah, it's here. Yeah, I got it. Thank you so much. Thank you. Oh, sweetie. I'm gonna try and then study it, and then I'll ask you questions whether you've done it, and then we discuss it. If that's okay. 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 Oh, okay. Oh, okay. Okay, then I'll try. I'll try and then do each unit, and then we discuss it. When I do one, we discuss it together and see how it's going. If I'm doing well or not. Thank you. When are you done with studying? Or you? Yeah, today. Oh, okay, all right. Then maybe tomorrow we could do that tomorrow. Oh, Sunday. I'll just try. When the time you're on, I'll just check and see. Then we discuss it. Okay, all right. You want to put it down? All right. Put it down. Nice meeting you. All right. Bye. My grandpa has this, but his car is full. Alexa. Uh,
Hello. Oh, I don't think I had audio that whole time, but anyway, I was just saying we're going to call the session here, and we'll pick it up tomorrow morning. But I was just saying it feels like a waste of time, and I guess we don't really know whether it's a waste of time until we see the results. But it just feels like I'm spending so much time on non-GAMSAT stuff. But I don't know. I feel like I'm building a foundation as well. I mean, we'll find out. We will find out whether it's been time well spent or time thrown in the gutter. But anyway, see you in the next one.